Hi, welcome to Math to the Power of Science. Today we'll be talking about quantum mechanics. First thing you'll need to know is that a particle is not either a particle or a wave, but instead is a packet of energy that can act like a particle or a wave. Imagine if you have a marble shooter and you shoot it at a random angle to a wall that has two slits that will hit another wall. The pattern on the wall will just be one hit spot and another hit spot. Something weird happens if you shoot something like a photon. If you shoot it once, you'll see that it has a hit spot, but if you go through many times, you'll see that it actually has an interference pattern, as if it goes through both holes. To test whether it goes through both holes, you put a detector in front of each hole to see which one it goes through. Well, this pattern seems like it's just coming from the marbles. Even if you repeat it with only one detector, it's still going to have the same result. To explain this, we're going to need to know what a wave function is. A wave function is the probability that it is at a certain point in space and time. Once you determine where it is, all other probabilities drop to zero. It collapses. This means that the photon goes through both holes, but when you look at it or detect it, it has to choose to go through the one hole or the other, not both. Another way you can look at this is if you have a cat in a room with gunpowder that has a 50% chance of going off or not. If you don't observe anything, the cat will remain being either dead or alive. But if you start to observe something, then the universe will choose whether it's dead or alive. Now, how the wave function collapse can be viewed as many different ways. It can be viewed as the universe splits in two, like if you have a film strip and you split it in two down the middle. This would mean that all probabilities already exist, and that it's just waiting to be peeled away. But the best we can do is guess. In our world, we can determine the momentum and position of someone, but in the small world, you can't. This is given you to an equation, and it says that when your uncertainty in the x position goes down, your uncertainty in momentum in the x direction has to go up. So as you become more certain of one, you become more uncertain of the other. This is the uncertainty principle. Partly because of this, particles don't move in straight lines, but instead move in chaotic and random ways. Now back to wave functions. If you have a particle with one wave function and another particle with the exact same wave function, you can't tell them apart. And when one wave function collapses, so will the other. This is quantum entanglement. To visualize it a little better, say you have two coins that will always be the opposite of each other. You flip one in the air and you flip the other. You look at one and it says heads. Then you look at the other one and it says tails. This is because it sent an instantaneous message to the other coin to be tails. This is because when you looked at the one coin, you collapsed the wave function, which also collapsed the wave function of the second coin, making the information travel instantaneously. Thanks for watching. Leave a comment down below or suggest a topic for a future video. If you like what you saw, please subscribe.